Hi. Hi, Olivia.
Hi, Nancy. How are you today?
Good. So, you graduated from California State Polytechnic University?
I did, yes. It's in California.
Okay.
It's kind of near Los Angeles.
How do you feel about studying in a college?
Oh, yeah?
Yeah. How do you feel?
I liked college.
Thank
It was pretty fun.
Okay.
Yeah, of course. Okay, Nancy. So, I'm going to just read the problem out loud, okay? And then we'll kind of talk about what's going on here. So, we have a rental car company. They rent cars for a flat fee of $20 and an hourly charge of $10.25. Therefore, the total cost fee to rent a car is a function of the hours fee the car is rented plus the flat fee. Okay, so we got to go ahead and look at it and see, like we were given some numbers, so we got to figure out what those numbers mean. And so we're going to assign some variables to stuff, okay? So our flat fee, what variable do you want to use for that? You just want to do an F for fee?
X.
You want to do an X?
F.
Or maybe we can do an F as rent fee. Yeah, so the flat fee, so our fee is
Can you write
20, right?
Okay. Oh, I saw that.
Because we says our rental car company rents a car for a flat fee of $20. So our fee, or our F, is 20, right? Okay. So now we have an hourly charge of $10.25. So let's say the hourly charge, we'll call that H, okay? I'm writing it right now.
Yeah. Yes.
And that was $10.25, right? So we have our flat fee is 20. Our hourly charge, H, is $10.25. Therefore, the total cost, C, so total cost then is going to be our T. They're telling us that. So cost is C. The total cost to rent is a function of the hours T car rented plus the flat fee. So then hours is T.
Yes.
Does everything we have on there make sense? So they want us to write a formula for the function that models this situation. So what they want is they want to know how much our total cost is. And we want to find out what our total cost is by using all of these variables.
Yes. It makes sense.
Does that make sense? Okay. So I think we can start off. We know that we want to know how much the total cost is, right? So does it make sense that our function is going to be C equals something? Yeah? Okay. So it says that we have a flat fee of $20. So that means that no matter what, you're going to pay $20 first, right? So you think we should put a $20 here?
Yes, we should.
Okay. So we'll 20. Okay. So it says the total cost to rent a car is a function of the hours T the car is rented plus the flat fee. Okay. So we just did flat. Now we have to add the function, so the hours T the car is rented.
Yes.
So we're going to have T hours, right? We don't know how many hours, but we have, what else do we have here that we should maybe multiply our T by? Correct. And that was what again?
Hourly charge and the hours T.
Good. So 10.25. Pretty bad. That's ugly. And then times T. Okay, so that would be a function, right?
Yes.
So, does that make sense?
Yes.
Good. Okay, so now for B, I want you to kind of think about this one, okay? So, find the total cost to rent a car 2 days and 7 hours. So, let's think. So, find the total cost, okay? We have an equation here that's for the total cost, right? This whole equation is to find your total cost. So we know we're going to use this equation, okay? So for 2 days and 7 hours. So they're telling us that our time here is 2 days and 7 hours. But at the time that they gave us 2 different ones, right? They gave us a day and they gave us an hours. But what is our T here? What unit? Is it days, hours, minutes, seconds?
Hours.
Hours. So what do you think we need to do?
Replace the hours T with 55 hours.
Perfect. Okay, so what did you get?
I think I need a calculator.
If you go up at the top on the left,
see.
there's a calculator up there. There, yeah. So it was 20. Yeah, there we go.
So the total cost is 183.75.
Correct.
Okay.
Good job. So now part C. So determine how long the car was rented if the bill was $432.73. Okay, so what do you know here, and what are you looking for?
We have the
using the variables
total
that we
cost.
have.
C.
What are we looking for?
The hour.
Good. Okay, so if our total cost C is $432.73, how are we going to find what our T is?
Replace the C with the bill.
The T or the C?
C.
C. Good. So I can go ahead and write it up here, but why don't you tell me what I'm writing? Oh, you got it? Okay. No worries. You already started.
Yes.
I know it's a little hard to write on there, huh?
So we should find the T.
Correct.
Is that right? Now.
Now what?
I need a calculator.
There.
Okay, it's 40 hours. Almost 40 hours.
Well, it's over 40, right? So you can just round. I would probably round it to the so places after point what?
40.3.
Good job. Is there any other questions?
All.
Any other problems
That's
I
all
can
I
help you
need
with?
for tonight. Yeah. Thank you. Thank you.
Okay.
Okay, thank you.
Yeah, of course.
Bye.
You're welcome. You have a
Bye.
good night, okay?
Can you hear me?
Oh, yes, I can.
Okay.
Oh,
Okay, let's get started on the problem.
yeah, I'm a high school student and I want to apply for your school. How about this school? Do you have any suggestions?
For my school?
Yeah.
Are you looking to apply to the University of Chicago?
Yes. Can you?
Why are you interested in the University of Chicago?
Because I think this school is beautiful.
That is true. What are you looking to study?
No, I'm not sure.
Okay. Because depending on what you are looking to study, different universities or colleges in the U.S. have different specialties. So you have this one here. A river flows due east at 1.5 meters per second. Right?
Yeah.
A boat crosses the river from the south shore to the north shore by maintaining a constant velocity of 10 meters per second due north relative to the water. A, what is the velocity of the boat relative to the shore? B, if the river is 300 meters wide, how far downstream has the boat moved? Okay, so the first thing to do is to set up a diagram with the velocities. So I'm setting up my diagram with this being the south shore and this being the north shore. We're going to label this point A, point B, and we're going to label point C over here. From A to B, that's the boat crossing the river. It has a velocity of 10. From B to C, the water is flowing at a velocity of 1.5. And this is asking, what is the velocity of the boat relative to the shore? Does that make sense? So using this information, we say the vector AB plus the vector BC will equal the vector AC if we're adding them head to tail. And if we want to rewrite that in terms of our velocities, then we say the velocity of the water, V, W, which is only in the, y direction. So we can multiply that by the vector I. Have you learned vectors like that? Well, with respect, so it's in the I direction, it's going to equal your V boat, like this. So then we can take that and we can plug in our values of the velocity of the water being 10 meters per second, and the velocity of the boat with respect to the shore being 1.5 meters per second should give us the velocity of the boat. So now we need to solve for it. In order to do that, we need to take the absolute value of the velocity of the boat in order to get rid of the unit vectors. Here we go.
Oh, sorry, I want to ask, are you typing?
Huh?
Are you typing?
Yeah, I'm writing, there's a little, on the top left, you see a word that says Tutor Me. Underneath that, it says Whiteboard. Underneath that, it says Board 1. and underneath that you have a toolbar with a bunch of options, one of them being the mouse. Next to that, there's a plus sign with arrows at the end of it. You can click that, grab the screen, and move it around. Or you can press 2 on your keyboard, and it should switch you to that automatically. If you can't find it even then, I can move it to somewhere where you can see it.
Okay.
Let me know. I can also try to screen share if that will help.
Oh, okay. That's good.
Alright, let me try that. Alright, so you should be able to see it now.
Oh, yes, I
Can you see it? Okay. Alright, so you can see all the things that I've written?
Yeah.
Okay, awesome. So now we just need to take the square root of that, which is going to be the square root of 102.5, which is going to equal the absolute value of the v-boat. And then we can just simplify, and we get that the velocity of the boat is going to be 10.1 meters per second. And that's how you get the first part of it. Did that make sense? Do you have any questions?
Oh, I got it.
Okay. Does it make sense? Do you have any questions?
No.
Okay, so let's go on to part B. So part B says if the river is 300 meters wide, how far downstream has the boat moved by the time it reaches the shore? So I'm marking this as theta, and this we're saying is 300 meters. All right, so the first thing we want to calculate our theta, which we can do by using these A to B and A to C, part of our ABC triangle. If we use our theta, then we can calculate the distance because we can use the arctangent to determine the distance. So we start off by saying the tangent of theta equals, here we go, v relative over v boat and water, which is going to equal what we have above, which is 1.5 over 10, which simplifies to 0.15. So the tangent of theta equals 0.15. In order to determine what that is, we have to take the arctangent, which will say that theta equals the arctangent of 0.15, which equals which equals 8.5 degrees. So now we have what our theta equals. Now using that, we know our theta, and we know that it's 300 meters across. So we can do this many different ways. One of them is this theta equals that theta. So you could just do the tangent of theta equals equals 3 x, which is the distance we want to find over 300. Then we know that the tangent of theta is equal to 0.15 from before. And then we just need to multiply that by 300. So we get 300 times 0.15 equals BC, which equals 45 meters. And that's how you solve the second part of it. Does that make sense?
Okay, I got it.
Okay.
Thank you.
Is this the only question you had, or did you want to go over another one?
No.
Okay, then have a good rest of your day.
Okay. Bye.
Bye.